Greetings, A-level chemists. Okay, here we've got a year 13 kinetics question. If you're a keen year 12 student, have a go. So this is from the 2023 paper, and what we're going to do is a whole little series on all the kinetics questions from the 2023 paper. So quite a tough question for 3 marks, okay? So this is 3 marks, and it's an initial rates question. And you're given this table of different experiments, 1, 2, 3, and 4. You've got to complete the gaps, gap 1, 2, and 3 for 3 marks, and you're given the rate equation, okay? So, first thing when I'm looking at this is that the concentration of A doesn't appear in the rate equation, so this must be zero order, with respect to the concentration of A. So what that means is the fact that the concentration of A is changing, that has 0 effect on the rate, okay? So let's compare runs 1 and 2. So in runs 1 and 2, we can see that the concentration of B is being held constant, the concentration of the hydrogen ions is being held constant. So the concentration of A is changing by some factor, and we're not even going to bother working it out because we know from the rate equation it's 0 order with respect to A. So the relative rate should be exactly the same as before because changing the concentration of A does not affect the rate. So 1 mark here. All right, that was your easy mark. So let's have a look at the next box that we have to fill in. So this one's slightly more tricky, but let's just go through this systematically. So what we're going to do is we're going to compare runs number 1 and runs number 3. So in 1 and 3, the concentration of A is being held constant. Okay, that doesn't even matter for our answer here. So the concentration of the hydrogen ions is being held constant. That does matter because it's first order with respect to the hydrogen ion concentration. So that isn't changing, okay? So that's not going to affect the rate. So the only variable that is going to affect the rate is changing the concentration of B. So it's second order with respect to B, okay? So let's think about this. We are changing the concentration of B by some factor, and let's call that factor a lowercase b. Couldn't think of anything more original. So if we change this factor, so the concentration of B by a factor B, the new relative rate is going to go up by B squared, okay? And I say go up, what I actually mean is going to change by B squared because it doesn't go up, it actually goes down. So the new relative rate is going to be B squared, and the new relative rate is 0.64, okay? So going from 1 to 0.64, we're timesing by 0.64. So that is the change in the relative rate from runs 1 and 3, okay? So we're changing this factor B for the concentration of B, and the relative rate is going to change by B squared, okay? And we've expressed that here. So to get what the factor of B is, what we have to do is take square roots of both sides. So if we square root both sides, that looks funky. So the square root of 0.64, I think, is going to be 0.8, okay? And let's just test that. So let's multiply 0.2 by 0.8. The best calculator, like cameras, is the one that you have in your pocket. So 0.2 times 0.8 gives me a new concentration of 0.16. Okay, I believe that is the answer. And let's put a box around that. And actually, let's just double check that, okay? So let's just double check because we want the marks. So what we're going to do is going from 0.2 to 0.16, that is times 0.8. So if we square 0.8, that should give us the change. So 0.8 squared should equal the new relative rate And this is for runs 1 and 3, by the way. So does 0.8 squared equal 0.64, which is our new relative rate? Yes, it does. So that is bang on. Okay, so now we can move on to the last box. And obviously, we've looked at changing the concentration of B. So now we're going to be looking at changing the concentration of the hydrogen ions. Okay, so we've compared runs 1, 2, and 3. So let's do 1 and 4. And I'm going to do that in a different color, okay? Just so it's clear. I'll try and see if this green works. So now we're going to do runs 1 and 4 for that variable. So changing A has 0 effect, so we can ignore it. So let's have a look, going from runs 1 to 4 for B, okay? So now what we're going to do is we're going to just look at B first, see how B changes the relative rate. Then we're going to have a look at the effect of the hydrogen ions changing the relative rate, because we've got two variables changing at the same time. So you can see that the concentration of B is changing and the concentration of the hydrogen ions is also changing, okay? So you've got two things changing at once here. So let's tackle B first. So what is that factor? To work out that factor, do 0.3 over 0.2. So 0.3 over 0.2 should be 1.5, okay? So what we're doing here is we're increasing the concentration by a factor of 1.5. If we do that, how is the new relative rate going to change? Well, the relative rate is going to be 1.5 squared, okay? Because it's second order with respect to B. So let's do that. So 1.5 squared is equal to 2.25. So I need to multiply that 2.25 by 1 in run 1. So step number 1, 2.25 times 1.00 equals 2.25. So that's our new rate for changing B. Now that isn't our answer, okay, because we're also changing the hydrogen ion concentration. We're reducing it. So we're not increasing it, we're actually reducing it. So let's have a look at how changing the hydrogen ion concentration affects this new rate, okay? So what's going on? And let's get my green pen here. So what factor decreases this? We're going to do 0.06 over 0.1. So this decreases by a factor of 0.6. And if that decreases by a factor of 0.6, the new rate is also going to decrease by that factor. Why? Because this is first order with respect to the hydrogen ion concentration. So where do we go next? We're at 2.25, but now this rate is going to decrease by a factor of 0.6. So 0.6 times 2.25 gives me a new relative rate of 1.35. And there is your third mark. Shabash. That was a long one. See you later. If you're enjoying this content, please subscribe to my channel and click the link in my description to sign up to my course.